I want to thank you for joining us today. Talk about the OCP Storage Project. I'm Ross Stenfort. Down here we have Lee Pruitt. He is my other storage project co-lead. And so you'll be hearing lots of comments from him as we go. So anything I messed up, he has to add. You'll be hearing if you're watching the video, the voice in the darkness will be Lee, adding necessary corrections.
Sniping from the peanut gallery.
Exactly. So with that, let's talk about OCP here. Let's talk about, a bunch of our success stuff from the past here. We got stuff on HDDs. We have the data center NVMe SSD spec. We have the data center SAS SATA spec. We have lock. Which is a security area of security, I should say. There's also our annual OCP Storage Tech Talk. I know some of you have watched it. You can find it posted on the OCP website and on YouTube. And so we have lots of different activities going on in the OCP storage group today, as you can see from all these contributions.
And just to add to that, so the Lock Rev 1.0, it has gone through the steering committee review, and so is in 30-day member review now.
Okay, I'm guilty for not updating the slide. I also want to talk about OCP Marketplace. Quick summary, 140% year-over-year increase in views on that site. Right now there are 32 listings for storage. Some of those are chassis, some of those are things to test with, some of those are SSDs, but you can find a whole bunch of things on the OCP Marketplace. I should add, 2 of the storage items are on the top 20 list of most viewed things on Marketplace. If you have questions about OCP Marketplace, how does it work, how do I list my products, what's needed, all those logistic things, I encourage you to reach out to Steve Helvey at OCP. You see his website, his email there, I should say. And I also provide a link here to OCP Marketplace, so you can go check it out.
And just for a little color on that, what we're looking for is when you want to do a submission, basically send in a list of all of the requirements that you aren't currently hitting. Hopefully there are very few, but just give us that full list, and then from that we have to do some negotiating and then decide whether we can put you on or not. So.
Yep. Let's talk about the OCP Data Center NVMe spec. Since this is one of the more known specs from this project. This started out in 2020 with Microsoft and Meta, and then in 21, Dell and HP joined the spec, and then Google came in 2023. Version 2.6 is on the website today. You can go and download it. The version 2.7 is coming soon. And it's really all-encompassing of what are the requirements you need to build a data center-grade SSD. That means it incorporates stuff from NVMe Express, from SFF. It incorporates things, incorporates stuff from PCI-SIG. It incorporates all the different learnings from all the people deploying drives and challenges they've experienced. So it really enables everybody to put more features, better quality, and faster, because you've consolidated people to focus in an area to build drives based on market needs. There is a QR code there, which takes you to a link for the spec. I wanted to talk about some of the features in the spec, since we get a lot of questions about this. But we'll start with the OCP Health Information Extended log. It basically has telemetry metrics based on scale. So based on large deployments, what are the metrics that are needed to manage your fleet effectively? Then there's the OCP latency monitoring feature. This does a couple things. Classic problem is, I saw a latency spike. Is it the drive or is it the system? Before this feature existed, what that meant is the supplier and customer argued for about 6 months. If you're lucky, you got figured out. And if not, you both give up. This feature is targeted to enable debug of those type of problems. Then you have the OCP formatted telemetry logs for human readable. Customers use this telemetry. It solves a couple problems. The first problem is it enables supplier telemetry to be read by customers in a human readable form. That solves a security problem. It also enables a whole lot more metrics to be customer readable and visible and knowing what's going on versus sending an encrypted binary and tell me something. Now you can actually parse these at scale and generate interesting types of things. It also means now that we have a spec, there's the open source OCP NVMe CLI. This is a CLI that is enables features in the spec, so there's an open source way of managing your drives at scale. And you can just pull that down and use it. There are lots of people who contribute to that today to make it very successful at managing devices at scale. There's also the DSSD power state support. It simplifies power states so that you can set your power to what levels you want. Lee, anything you wanted to add before I keep going here?
Yeah, so like on the DSC power state stuff, it's kind of really meant for at-scale power capping, so that if I've given rack, I can only go to a certain power level, I can set that state, and it's kind of, the SSD may not have this specific power state that I requested in its NVMe power states, but it will then go and run at that next lower level from what I specified. So it's a way of controlling the kind of cap level of power that the device will consume.
Thanks, Lee. Yeah. And I should have noted, you know, all these things are based on problems at scale, where there's collaboration based on the problems we've experienced of how do we pool our resources to solve these problems, because we're experiencing them now, and how do we build a better drive. Some other things here, hardware component log. You know, this is targeted at how do we get some of the manufacturing information of the device so we can figure out, do we have yield problems? You know, the passing serial numbers around, generating a bunch of statistics from serial numbers is very hard. It's much easier if that manufacturing information is on the device, and then you can just go pull all your devices and generate the statistics around that to figure out if you have manufacturing yield issues. Or if you do have yield issues, as a way of identifying it rather than relying on passing serial numbers around and lots of confusion.
I tell an antidote. So the specific on this is why we wanted this is at one point we had an M.2 device that after 8 or 9 power-ons would then burn out. And the root cause we found after quite a long time was that a given lot from a given manufacturing site had misregistered 2 layers of the PCB, and so the vias for the power were just offset enough that after just enough time to get into the data center, they would burn out and we would have a dead device. And so if I had had the lot codes available, we could go in and look at that, and because we harvest this stuff and it's all part of a manifest, we would have known that, oh yeah, everything that's burned out here is all from this one PCB lot, and that we could track it down in days instead of months.
Thanks, Lee. Device self-test improvements. Device self-test, it's a great feature. You can go test your device. The challenge that the OCP spec fixed was commonizing the codes that you return when you find problems. Before this existed, within the same manufacturer, the codes for the same problem might be different generation to generation, and the codes between suppliers are different to different. So having everybody return the same code if they have a DRAM failure really makes it much more efficient for everybody in aligning codes to be common and standardized compared to being effectively random numbers from the customer perspective. Device self-reported power. This is a great feature. It's in the new NVMe 2.3 spec that got released. As with all features, you know, there are required features in a spec and there are optional features in a spec. So this took, you know, what was built in NVMe and defined, you know, what are the requirements for a device around based on what NVMe built. And so this is very useful in that it enables, through software, to take max average power measurements, histograms, and other related power capabilities that today are very painful, take very long time, and cannot be done at scale. Let's also talk about the OCP Data Center SAS SATA specification. This is a collaboration with Microsoft, Meta, HPE, and Dell. This spec is contributed. You have the QR code there so you can get to it. And this is very similar in concept in that for an HDD, it defines the features that are needed, as there are many specifications out there, but what's not clear is what is required versus what is optional versus what's the other stuff in between those things that are not in the specs that you need. Some things in the 1.5, the OCP SAS SATA telemetry. This is basically the ported telemetry from the OCP Data Center NVMe 2.5 spec. It enables human readable debug logs. Also, we reworked the transport mechanisms for SAS and SATA. So SAT translation is supported, added HDD specific debug metrics and divided up into what's common, what would be needed for SATA, SAS, SSD versus an HDD only metrics, and added a whole bunch of replacements for smart attributes so it's all commonized between the customers and there's one method to do it. Lee, anything you want to add to this?
No, that's great.
Wow, I didn't get corrected for anything. I should add there's also the TCG configuration and history logs. These are also ported from the SSD spec to help keep track of things. It just makes it easier in deployment. And also security was also updated to harmonize the two specs. Security is really about media and how do I protect my media. And so then the question is, how does that apply to different protocols? So helping to clarify that and making it much clearer, you know, makes the world a better place. There's a feedback CLA process. As I'm talking about this slide, I realized I should have pointed out Mike Allison, he's here. He's our OCP steering committee representative who spent a lot of effort in driving this with OCP and making this happen. So I really appreciate all the effort you put into this. So OCP has implemented a feedback CLA process, enables the authors of a specification to use feedback from non-authors on a specification. And whereas the author's discretion how to use the feedback, and it enables people to provide feedback on a specification before it's contributed and in a way that everybody feels comfortable. You know, for more information on this, I'm going to point out Mike Allison here. If you're interested in the data center NVMe SSD specification, if you're interested in lock, also go talk to Mike. I don't see Dave Landsman here in the room. I did see him here earlier today. But if you're interested in the OCP data center SAS SATA specification, talk to Dave. He can help get you signed up. But the feedback CLA is a great way to provide feedback to people working on specifications before it's contributed so that things can be modified such that it could be clarifications to make it more clear. It could be there's stuff that's wrong. And it just leads to higher quality specifications. Other things. Our project meeting is second Monday of every month. There's a link here to the calendar. I encourage you to dial in. I could say this last month, for example, our topic was E1S and cold plate and single-sided. You know, we had a lot of people there to have a very lively discussion about their opinions on how this should be done, what are the problems, and so forth. If you have a meeting topic, reach out to me, reach out to Lee, and we can work at getting it on the calendar. Lee, you have anything to add here?
Yeah, and so obviously the next kind of big conference for storage coming up, well, it's more than just storage, of course, it's the OCP Global Summit, but we do have on the Thursday, we'll have an all-day track for the storage project. And so we've got 20 plus presentations and a couple of panels. So hopefully some people can make it to that.
Great. And with that, are there any questions from the audience? Yes. Here, Lee, are you going to pass the mic?
Yeah. Pass it down.
So I'll use a power example, your power spec as an example. The self-reporting, how do you police the self-reporting against reality, say as measured with a power meter?
Lee, I saw your hand go up.
Oh, sorry. Here, catch. Throw it.
So the way usually this is designed in the SSD is this is coming live from the PIMIC, right? And so it's the data into the log comes from the PIMIC, and so it's quote unquote real data. Obviously, if it could have bugs or it could have offset issues, things like that, or somebody could be lying. But as part of qualification, we will double check, right? So we will have a power meter attached to that device. And we will then read the log as the power meter's reading in. We're going to read the log out and see that they match closely. The customer, yeah, the customer, right? So we always, each of the, all of the hyperscalers, we have a quite rigorous qualification cycle that we have to go through.
Let me add to that. So the specification obviously defines the target of what you need to do. OCP does not have your traditional compliance type of test suite. There are third-party test suites out there to test things. So those do exist, and those are those companies' value add, but it is not, it's not an enforced type of system. The customer needs to decide what's best for them. So I hope that helps answer your question. Paul, I see your hand in the back.
All the way.
Expand on where you see security. Oh, all right.
Ross, could you expand on where you see security going? Obviously, there's lock. Are there other places you'll be heading in the future?
Paul, you as the security person, it's a little intimidating asking that question. As you know, there are many committees and many forums and organizations talking about security. What I can say is from an OCP SSD spec perspective, this is what the customer is asking for. And so for how all those things come together, different customers will have different opinions, but at the end of the day, the value add will come from what is in the spec is what customers are asking for.
Okay. Are you getting any hints of people being worried about having, for example, in a self-encrypting drive, too much data encrypted with a single key, especially as the drives get much, much bigger?
Lee, looks like you're anxious to answer that question.
So yeah, there's, along with the lock and the entropy and all the stuff we're doing with that, there's always key rotation requirements after a certain volume of amount of data that has been gone across, right? So the idea is that those are policies that we need to enforce at a higher level, and we do within Azure, right? So, but some other security things you can think about, obviously, Calyptra and lock. Those are very important. Streaming boot is something that's coming up. Kind of one of the things that we're looking at is like, do we really want to have firmware in the device at all? We'll just stream it every time, right? And we know it's good because we've measured it from our side, our HSM silo, that sort of thing. So
Okay, I think we got time for one, maybe two more questions.
This is in continuation to the previous talk on the E2 form factor, which was recently introduced. Is there a plan to add the data center thermal and power requirements for E2 form factor in the future specs for?
Good question. So it's a multifolded question. The 2.7 spec coming does have E2 items in there, but realize the base spec, for lack of better description, is SFF TA 1042. And in SFF, there are plans to add thermal methodologies for measurement. Now, each customer at that point will also, though, have their requirements of what capacity, performance, whatever. And those are not going to be in any of these specifications we're talking about.
Thank you.
One more? One more? Going? Well, thank you, folks. Oh, of course, last microsecond, John.
I will note that if you are interested in correlating power, SNIA has recently published a green power device spec, which actually tests power and can be used to correlate to the self-reported value.
Great. Okay, I think we are good today. I want to thank you for coming today, and thank you for all your time.